Hello everyone, I'm Brut Code. I'm a 14-year-old developer. Welcome to Brut Code, and in this channel you learn Web3 coding from a 14-year-old guy. Hello everyone, you're watching Brut Code, and in this video we are going to code our first smart contract. So let's get started with Remix IDE. We will be coding the smart contract in this IDE. So to get started off, create a new file. I'll be just naming it test. So first we'll define the version of Solidity. So to do that, type pragma Solidity version 0.8.8. So we'll be using version 0.8.8, and then we will define the new contract with the word contract. This is a keyword in Solidity. So I just name this contract as test, and now we are going to learn about types of variables. So let me just remove this warning by defining the license. So in later versions above 0.7, Solidity requires the license of contracts. So spdx license provider, you could set it anything like MIT or PPT, but I would use MIT. So let's get started now. Something error. PDX license identifier, so it is identifier. Now we will define so first let's start with defining an integer. So to define an integer, you can type int and the name of the variable. So I'll type like negative, which is equal to, so this is a negative integer which is -8, let's say. So now we will just compile and deploy our script, but before that we will edit this visibility to public so that we can actually access the variable. Now we'll deploy it. Here now you can see we have got a button called negative. When you click it, you get the value of negative. So now if we it is integer, so we can define either negative or positive values. So let's define 9 and let's deploy it again, and we have 9. So now this was of integers. Let's move on to, wait, let me just defines positive as well as negative numbers. Let's move on to unsigned integer. So as you know, unsigned integer is basically an integer without a sign. So integer without a sign is called a positive integer. So positive integer we can take as 60 or any number which you like. Defines only positive numbers. Positive numbers. We will just add public. Yes, public is added. Now we can add, so now there are various types of integers, unsigned integers. There are bytes. So uint 8 means if you want to store a value which is smaller than 256, so you can store it in uint 8. So let's store like max value is equal to 255, one less than the maximum value. So its max is 256. So this basically saves cache keys and also is faster than traditional uint. Next is uint 256. This is the largest standard. So if you want to store huge numbers in millions and trillions, you can store it here. So we can pick number. So this, let me just make it public and public. Big number, so we can store like something like 40 into 10 raised to the power of 18. So this will be 40 and 18 zeros, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18. So huge numbers like this can be stored easily. This is this is not cache efficient, and it is used for decimal representation in ERC tokens. ERC tokens. Next, we are going to see string. So, as you know, string is just basically a line of text. So we can input here in. So we can add here any line of text, like suppose. Let me just yes. So we can input here any line of text like this defines text. Next we so let us first compile this and deploy it. Let's check how much we have got here. So the big number should be this value. So it's here. So this is uint 256. Basically, when you define uint and you don't give it the byte size, it will be set default to uint 256. So now let's check the max value of uint 8, which is 256 but one value less in order to avoid errors. Negative number -9, positive number 60, and a line of text. I lost key. So the next type is bool. If you come to Solidity from other languages, you may be knowing about bool. Bool is a variable which is either true or it is false. So we can set it to either true or we can set it to false. And then we have something called as bytes. So this basically converts a string to bytes. This is used in advanced. This is an advanced variable uh, used in low level coding. So we would just be looking it from above. So bytes, we'll say byte code is equal to, and the line of text I would keep it as let's say this is a transaction. So this returns the value in bytes. Let's see this. We will deploy our smart contract and we can see a true or false. It returns false as the value we have set here, and the byte code returns the bytes. So this uses basically Keshak 256 algorithm. If you want a separate video on this algorithm, please comment down below. And then moving on, we have, so let me just revise. Bool, bytes, yes, we have the address. So if you want to store your address in your smart contract, like the owner address, owner is equal to, let's say, the contract address, the first address from the account section. So we are basically deploying this everything on the Remix virtual machine. So we'll take the first address from here and we'll say this defines the address. This stores the addresses, and yeah, basically that was all. Another bonus is that we would be changing the values of these through functions. So before that, let us check what have we got till now. Big number is basically uint 256. Byte code, we have got byte, which is Keshak 256 hashed. Max value is 255 of uint 8. Then we have negative integer. Then we have the owner address. So this is the owner address. Then we have the positive integer, a positive unsigned integer, and then we have the text, and we have the bool value. Now let's implement it in a function. So we'll say function, and we would say change uint, and then this would carry a parameter called uint, which is choice. Yes, it will be public, and we would be changing the state of, let's say, positive integer is equal to the choice. So what is going to happen here is that we would input a choice, and this choice will be set to the value of the positive integer which you have got here. So let's redeploy it, and here we have the function. So first let us check the value of positive integer. So now it is 60. Let's input as 40, change event, and now if we check the value of positive, it is 40. So you could easily, you could do this function for other variables also. Like if you want to change the string, so we would just change the function to change string. And then strings have special functions, like strings have two types, which is memory and storage. So if you want to store the inputted value on the blockchain, it would be storage, and if you just want to access it, it would be memory. So now we have the string memory choice public, and now we would just set the value of text to the choice. Yes, so choice is a temporary variable, it is not stored anywhere, so we can use the same variable here also, string memory choice. If you want a separate video on memory and storage, please comment down below. So now we would redeploy it, and now we have two functions, change uint and change string. So if we look at the string, it is I lost key, and if we change it to like this is amazing, and now if we check the value of text, we have the value over here. So you could basically do this. This is your first smart contract in Solidity. In the future we would be coding hard smart contracts. We would be inheriting smart contracts from other contracts, and we would do it advanced stuff. So that was all for today. Thanks for watching, and please care to subscribe and hit the bell icon. Thanks for watching, guys.